This conference will now be recorded.
Yeah. Okay. So this is one simple diagram. Okay. Rather than complicating the database architecture so much, as we saw in the previous diagram, right? This one. This is very complicated. Like understanding it is very difficult. So for that purpose only, we have this smaller diagram. Now this smaller architecture diagram. So what, as a performance engineer, what are the components which we are interested in? We are not interested in all the components, right? So what, like as a performance engineer, I am more interested in few of the components, like the memory management or the data storage, okay, the hardware behind it. So those are the things which I am interested in. So this is the architecture of which focuses on that, like here we will get the simple overview of what is a database architecture, especially about the memory. Okay, because what happens, right, the most of the time the queries take more time when the memory operations are not performing well. Okay, so we need to understand how these memory operations are working. And also here also can understand few of the functionalities, like the redo logs. What are these redo logs? And what are the why is this redo logs used? Okay, what is the database buffer cache? And all those we will understand in detail, okay, one by one. Okay, now as we see in this diagram, first it starts with the user process. Okay, so Oracle DB is a multi-user database, so n number of users can perform the activity at the same time. So how do this Oracle handle this n number of users at the same time? So it uses something called a session ID. Okay, so based on the session ID, it creates a session. Okay, and that session is passed to the server process, through the server process, to the PGA. Now what is this PGA? It is called the private global area. Okay, so or sometimes it's called program global area also. So now by the name itself, what is a PGA? Like from the name itself, it is like private global area, program global area. Um, so it is a memory area that is dedicated to one single user. Okay, so how much ever users will be there, that many PGAs will be like that many private SQL areas will be created inside this PGA. Okay, so this PGA is where the individual user process is stored. Okay, now once the PGA, like once this section is done, it will enter the SGA. So there are two different memory allocations inside the Oracle memory management. One is SGA and second is the PGA. So SGA is nothing but, here we have different, we can say that it's a shared global area. Okay, so what is a shared global area? So here is like here we don't have different, like it is not like, okay, there's only one user. Okay, here the processes are happening together, because we can't have different memories for all users, right? So only in the PGA we have different memory allocation for each user, but inside SGA the processes are happening simultaneously, like it's a mixed process. So to handle this, there are different components inside SGA. Okay, so if you can see, there is shared pool, there is large pool, there is Java pool, there is streams pool, there is redo log buffer, there is database buffer cache. Okay, and in after SGA there is a storage. Okay, what is the storage? So here the data is really stored. It's a disk. Okay, we can say some hard disk or SSDs where the data is stored. And this is a redo log. This is also again a storage where the redo logs are stored. Now we will see this, what are all are they, like what are these in detail one by one. Now let's understand what is inside the SGA, right? There are different shared SQL area, data dictionary cache, result cache. So let's understand these in detail one by one. Now, one thing we need to understand, these are caches. Okay. Now, Like, can anyone say me why this SG and PGA are called caches and not a memory? From the name, like just okay. So because see, if you see any memory management, okay, the caches are the fastest one. Okay, so these disks are not that fast as SGA and PGA. Okay, so whenever we need to get the data more faster, more the data, like whichever type of data we need, more like where we can make it faster. So those type of data are stored in these caches, right? So that's why this PG and SGA are called caches, and these are storage, or the we can say no, normal memory. Okay. Now let's understand this in little detail. These components inside. Okay. Now, as you know, PJ is program global area and SGA is shared global area, we call it. Now, shared global area, right? This shared global area, it has one component called shared pool. Okay. Now, it is a very large cache. This shared pool, only this shared pool. Okay, I'm talking about this one alone. Now, in this shared pool, it's a big memory area cache. It has a library cache, it has a result cache, and each has their own specialized purpose. Okay, now let's see one by one. Now one of these cache is data dictionary cache. Okay, now what is this data dictionary cache? Whenever, like, let's say, like when you are running a query, okay, for example some select star query or something. Okay, now to check whether the select star query, like to check whether the like whether that query is a valid one, we need we don't need to go to always the storage, check the databases and come back, right? Now there is an easier way to do that. What I do is I store the database information or the database definition inside the data dictionary cache. Now what is this data dictionary cache? It will have the definitions like the column names, the row names, the indexes. Those definitions will be there inside this data dictionary cache. So in that way, whenever someone from the PGA or as a user runs a query and the SGA gets a request, okay, it will first check in the data dictionary cache whether that query is proper or not. Like let's say select star some I say some salary. Okay, it will check whether the salary table is there or not, or salary column is there or not, or salary row is there or not. Okay, so how does it check that? It doesn't need to go to the database all the time and check it. So what it will do is it will check the data dictionary cache first, right? So data dictionary cache is the place where the table definition is stored. Okay. Now next is so like am I clear? What is the data, like what is the table definition meant by? So all the table related data, like the table summary we can say, or the table indexes, column name, rows, those things. Okay, that's called in general, like in a layman term, that's the table definition. Okay. Now uh, this is about the data dictionary view. Okay, next is the next let's see what is this result cache. Okay, now if you run a query again, okay, so each time, so when you run a query, what will happen is first you run the query. Yeah, so next let's see the result cache. Okay, so what are we seeing here? So result cache, so we are now focusing on this one. Okay, the result cache. Now, what is a result cache? So whenever you run a query, okay, once you run the query, it will return some result. Okay, like let's say I want the list of all the users with a salary above maybe 1 lakh or 2 lakh. So it will return some result. Okay, so that results which are run are stored in the result cache. So that if the same query is run or the same query is run next time, it will not go. So when the same query is run, okay, it will not go to the data. Okay. So whenever now when a query is run, so let's say a user runs a query. Okay, it will go to the PGA. Now what the PGA will do is first it will go to the data dictionary cache. Okay, it will check whether the definition is okay, the query is correct and all. Then after that it will go to the result cache. Okay. Now why it is going to the result cache? It will check whether this query was run before and we have the result in the result stored already in the result cache or not. Because from here going here and fetching it is a costly affair, because we don't want to waste the time. It is not a cache. It will take more time than the caching memory, right? So we need something which is more faster. So we will pick that data from the result cache. In this way, what we are doing is we are optimizing the time by picking it from the result cache. So that's why when you would have observed it, when you are running a query, just a minute. So when you are running a query, generally, okay, so the first time when you run a query, it will take a lot of time. Okay, but later on, when you run it second time or third time, it will be like it will feel it's executing faster. Okay, so that is the thing about the caching. Okay, so for the first time it is being picked up from the data storage or the data disk, but later on it is picked up from the cache memory. Okay, the result cache. So that's why you are getting the result very quickly. Now after the result cache, we can see what is the shared SQL area. This is little bit like you might not get the gist now, because this shared SQL area is nothing but where the execution method is stored. Okay, so what happens is generally there are different types of execution methods for a query. Okay, Oracle has different types of we can say procedures. Okay, to to decide how it will execute some query. Okay, now that is stored inside this shared SQL area, so that whenever you get a query, it doesn't need to go again always to this data. Okay, to fetch that execution method. Okay, so those execution methods will be stored in the shared SQL area, from where it will quickly pick up that method and it will execute it. So that is a shared SQL area. So in this way, shared pool has shared SQL area, data dictionary cache, result cache. Now these components we will be seeing more in in-depth detail, because there are further components inside this. So that we will see as we progress. So any question, anyone in this shared pool?
Yeah, so the result cache, right? So what is the duration that the results would be stored in this particular cache?
Correct. So that we will see as we progress. So what that we can set, like basically it is a algorithm by Oracle only. There is something called automatic memory management also. Okay, so that we will see as we go ahead. That time it will be more clear about the duration, how much, and all those questions.
Okay, thanks.
Yeah, yeah. In any other queries, anyone? Now this is please take it like this very, because this architecture is very important, because these configurations are tweakable. Like though it is not given, like generally it is not given access directly, because people don't ask. Okay, so but generally to tune anything you can really tweak the configurations. Okay, you can tweak the values. There are different parameters which we will see as we progress. which we can tweak, because this memory is a main bottleneck whenever there is a performance issue in the database. Okay, so because there will be generally like 80% time it will be low memory issues. Like let's say PGA memory is less or SGA memory is less. So though automatic memory management is there in Oracle, sometimes right, like the algorithms are not that perfect, so we need to tune it manually. So that for that we need to know what all components are there. Yeah, go ahead. Anil, is it?
Yeah, this is me. Sir, due to internet problem, I was not able to understand the PG and this said SQL area. Can you explain?
Okay. Yeah, I
Yeah,
will explain again. Okay. Okay, so let's see from first. Okay, so here we have a user process. Okay, so a user is, let's say, here he's running a query. Okay, so after the user process, it will enter the server process. It is generally our server, our DB server. We are entering. Okay, as soon as we enter, there is one memory area called the program global area or the private global area. There are multiple names, but the most common one is private global area. Okay, it is called private global area. Now after the PGA, it will enter the shared global area. So we have this total area. Okay, total what we have SGA is called the shared global area. Now what happens is generally PGA will have all the user data individually. Like each user will have different types of queries, different data. Like one user will be running select star sale or select star payment pay. One user will be running select star maybe some other star, some all this. So this separate thing will be stored in the private SQL area one by one. For each user, there will be a small memory allocated inside the PGA. Okay, now from here, all together will be collected and sent to the shared SQL area. Okay, so once we have all these memory in the PGA, all these will be collected in a specific batch. Okay, so that it's handled by Oracle. Okay, so there is no specific like okay this much. But there are details, but it is very deep. No, we don't need to know for now. That is a little again advanced concept. But in batches. Okay, so this memory, this PGA is set. All the stored things are sent in batches to the shared SQL area to process. Okay, or let's say we can say it is sent to the shared global area to process. So first it will go to the shared SQL area. So inside SGA there is a shared pool, right? Inside shared pool there is a shared SQL area. So this is the area which I'm talking about, the shared SQL area. Now this batch will enter the shared SQL area. Here the execution method will be decided. Like what type of execution method we will see these execution methods in detail as we progress. For now, like you just understand Oracle has different types of execution methods for different queries. Okay, so that will be decided inside the shared SQL area. Now after that, for these queries, whether the definition is correct or not, that will be checked inside the data dictionary area. Here the definition will be checked. So what is definition? Whether the query is correct, the table what they are using is correct. So those things, okay, will be checked here. Because if the definition is wrong, I don't need to go to the next step, right? Because the query itself is wrong and it's not related to our table or something. So we stop there. Then after the definition is checked, it will move to the result cache to check whether that query was run before and do we have the results now stored in the cache. So for that purpose, we will go to the result cache. Now, if this data is not there, like it's a new query and we don't have the results, it will go to the database buffer. We'll see. We will see that what is this database buffer cache and the data storage. So if you see the flow of data no, in the shared pool, first it will enter users process, server process, private SQL area. It will go to shared SQL area. Then it will go to the data dictionary. Then it will go to the result cache. In this way, the process will move on. And there is one other section also inside this. And other, like the other caches which are inside this are little advanced concepts. So we don't need to see that as a performance engineer. Okay. As a DBA, you might have to learn more on that, but this is not that much required. And because we don't have that much control over it also. Okay. It's controlled totally by Oracle. So here we are focusing on those components where we have good control over, okay, in the configuration or those details where we can control well. So Anil, is it clear what is SGA and PGA? So
Yes, sir. So
SGA,
PGA, so PGA
yeah,
will be like a specific for a single user request, but SGA will be like a common for all those stations, right?
correct. Yes, yes, correct. Yes. So SGA, that's why it's called shared global area, and this is private global area.
Okay, okay, sir. Thank you.
Yeah. So any other question, anyone? Okay. So let's move on.
Vishnu, one question. So when we talk about SG and PGA, so are we talking about the main memory?
See, this is a caching memory of Oracle. Okay. So basically, it's not the main memory. Main memory is this one, the where the data is stored. Okay. This is the cache. PG and SG are caches.
Okay.
Yeah. Okay. So let's move on to what is the database buffer cache. Okay. Now, I think like generally you understand, like you all understand, right? Like, why we are doing this? Because see, when this memory is something which is very expensive. Okay, so we can't utilize that every time. So we here using this memory architecture, what Oracle is trying to do is to optimize that usage. Okay, like whichever is repeating, it is trying to reduce. Okay, so things which are getting, like let's say some same thing which we are executing 10 20 times, it is executing once, and in that way it is reducing the memory usage. Okay, so these components are helping to do that. That's what is basically happening. Okay, that's all. And this is, and inside this also there are frequent tuning happening in the Oracle side. Okay, like they are creating new, like they're improving the data dictionary cache, they're improving the result cache, so that it becomes more and more better. But in general, these are the main components inside the Oracle DB memory management. Okay, because from here only the things happen as we progress, like the cleaning process or the caching process, everything happens in this whatever you're seeing, the components in front of you. Now let's see what is yeah, so let's see what is the anyway we saw what is everyone clear what is a library cache, this one?
No, sir.
No. Okay. See, here, see, basically library cache, we say it has the SQL statement process information. Okay. So now what is this SQL statement process is, see, whenever an SQL is run, okay, or a SQL statement is run, each SQL statement has different process of execution, like how it is executed, like selects, for as simple, I will explain you very simply, okay, what it is. So let's say I have a select star statement, okay, or I have some join statement. Now select star and join both will be executed with a different process, right? Like both are, though it's a SQL language, but how the Oracle will process it, it can process it differently, because or some sort statement is there. Okay, so all these statements have different process to execute it. So that process is stored inside library cache. Like if you get a sort statement, what should be done? If you get a join statement, what you should do? So that those information, no, is stored inside the library cache. Is it clear now? In a simple term.
So, sir, I mean, it is a different. I mean, then what is the difference from execution method which has been decided in the said SQL area?
No, no, sorry. Can you repeat that? I didn't get your question.
Yeah. So how it is different from the execution method that which is decided in the shared SQL area? Like it is
Yeah, so
same
so
or
that's
is it
what.
different?
Yeah, same. So what I meant is the execution method is what I meant by the process. So to make it simpler, in simpler words, so how the things will be executed, right? That's what is stored inside the library cache. As simple as it, because it doesn't need to pick up this always from the storage disk and come back. So this will be stored in the library cache. So next time some statement comes, it knows like what method it needs to choose to run this type of query.
Okay. Okay.
And also one important thing is, see, whenever we decide the SGA size and the PGA size, no, higher the size, more the better. But the problem here is we can't keep infinite size, right? Because it is a again expense, it is a cost which we need to pay. So that's why the size of these memories are also very important. So we need, whenever there is a performance query issue, it is due to the memory low issues. Like either the PGA memory will be low due to number of users increasing due to the load, or the SGA memory will be low due to the load again. Okay, so more the traffic, more the memory you need. Okay, so that we need to take care. So if you optimize it, like let's say, if you can optimize, like without optimization, if you need just a simple way I'm talking about, okay, if you need some 100 MB or 500 MB of data, storage, this is very low I'm saying, but yeah, just I'm for an example. Okay, if you tune it, you can bring it down to 50 MB. That's how powerful the tuning methods are in Oracle. Without tuning, it will go to 500 MB, and which is a lot of cost for the organization. Okay, so that's why memory tuning is very much important in SQL or the database performance engineering. Yeah. So next let's see the buffer cache. Okay, let's understand what is a buffer cache. Now this buffer cache, right, we will see it in more detail as we progress. But for now, just in a simple term, okay, I will explain. This is the part which I'm talking about, okay? This is the buffer cache. Now what is a buffer cache? So you see, the buffer cache you can think as a memory, okay? Here the data is stored for a short period of time, okay? So what it is like, if I get some data, it's, don't confuse it with the result, okay? Here only the results are stored. Here the real data is stored, okay? Now what is this is like, let's say I have some customer data, okay? Like some orders, number of orders. Like I have a table of customer data. Like I have a table of customer data, okay? So now this customer data is being pulled by the PGA again and again. Like let's say it is happening very frequently, okay? So rather than pulling it from the data always, what this Oracle will do is it will pull from the buffer cache. Now what will happen is, if there is some data, okay, so let's say some data is coming which is not available in the buffer cache, some new statement, okay, which is not available in the buffer cache, what it will do is it will go to the data storage and it will pick it from the data storage and write it to the database buffer cache first, then it will deliver it to the PGA. Okay, now what happens is, sometimes if you see there, PGA can access the data directly from the storage disk also, but only accessing, it cannot write anything, okay? Only reading it can do, it cannot write. So always writing can be done only through the database buffer cache. So anytime if there is some issue in the, if you're seeing, okay, some query is being executed a little slow, or the write speed is not that much, so there could be some issue between the storage and the buffer cache. Okay, so that's, this buffer cache is like a buffer memory before the real memory. Okay, so here the data which are frequently used are stored, and these are cleared like frequently, okay? Like it is handled by the memory management algorithm of Oracle. So whenever this database buffer cache gets full, it will remove the unwanted one. We will see when we see the database buffer cache in detail, that time we will see how it is done, okay? Like how the data is removed, after what and when, okay? So that we will see. For now, you just understand this is a secondary memory which is faster, okay, than the main memory. And here it is the most common data is stored so that it can be picked up very easily. Now every time it will not go to this data like the storage disk, okay, it will go to storage disk only when something alteration happens. So some writing happens. Now what is writing? So let's say I have some process where I am inserting an order ID into the table. Okay, now there is some writing happening, right? From PGA it comes, it goes to your database buffer cache, then it will go to the storage disk also. It will write that order ID, okay, and it will be stored in the database buffer cache also, both. Okay, so whenever the writing happens, whenever a table is altered, okay, whole database buffer cache is stored, okay, restored. Like whatever was there before will be deleted, and a this new table will be written automatically. So whenever an alteration happens, this thing will be automatically written. Okay, so database buffer cache will be totally renewed. So this is one more point which we need to remember. So that's about database buffer cache. Any question related to database buffer cache? We will see in further lectures little detail. For now, but whatever like in basic terms, what it is. Is it clear to everyone? So to summarize, I will to clear like so that all are clear. One, it is the closest memory that stores frequently used data. Okay, that is the first point. Then the second point, first is every time whenever there is some data written, okay, it will be written to the database buffer cache first, then only it will be written to the storage disk. So always whatever writing, reading, everything happens, no, it will always happen through the database buffer cache only. So this is like an intermediate between the data storage and the PGA or SGA activities. Okay, so nothing will go without crossing the database buffer cache to the storage disk. Only the read activity, where only the reading is there, can happen directly from PGA. Like if there is some query, okay, so Oracle feels like it doesn't need to go to all the SGA. Directly it can pick that data from the, because if there is no processing or anything required for that, then it will directly pick that from the storage. Yeah, so that's about the database buffer cache. And also the main important point you need to remember, whenever any alteration happens to a table. So what I mean by alteration is like some new data is written to the table, or some data is deleted from the table. That time the whole database buffer cache is there, right? So obviously if there is some same table, okay, some table A. So table A, before it was written inside the database buffer cache, totally it was stored. Okay. Now I have altered this table. Okay. Once the alteration is done, what Oracle will do is it will automatically delete the old table from the database buffer cache, and it will write the new table A which with the new alterations. And at the same time, it will write it in the storage disk also, so that both the places consistency is there. So if you see, every time this consistency is there between the storage disk and the buffer cache, that is also maintained properly. Okay, like it's not like buffer cache will have different data and storage disk will have different data. That consistency will be there always. So that also we need to remember. Any question, anyone?
Hi Vishnu, like you said, like read queries will directly done from PGA to from data. PGA can get the read things directly from the database, right?
Yes, yes,
So any alterations like writing to the database will be happen from the buffer cache, right?
correct. Yes,
So if you do like some read statement like select star from some data table like something, whether the
yeah,
request goes to the buffer cache and to the data, because that is a read, or it will directly goes to the data and it will get that read. How it will be? Like earlier you said,
So
some select
yes,
star, it will directly goes to the shared global area and it will check it there and it will select. You said.
yeah. So see, that's why I said. So no need to confuse with the result shared pool and the database buffer. So here there is a real data which is stored. So shared pool has these methods, these results, what it is, but the real data, the numbers like the customer 90, customer numbers like 91, 92, 93, whatever, those data is stored here in real. Result cache, only the result is stored. Like whatever the, like if when I do some join some operation and the result comes, okay, that result is stored in the result cache. So here the real data is stored. So some operations are happening, like even the shared pool does some operations or something, okay, so that time it needs to get that, like let's say I need to do some operation like table 1 minus some table 2 or something like that, some join, okay, so I need to get that table 1 and table 2, no, so that will be picked up from the buffer cache and it will be given to the shared pool or whichever area of the SGA it requires, okay, and from there it will be transferred to the PGA, or if yeah, so that's way. But one thing is that only the write process will and read process will happen to the database buffer cache. Read process, if there is some query where only reading is there, like it's a very simple statement, like where Oracle, like there are Oracle algorithms, right? So it knows, okay, it doesn't need to go to the whole SGA process for this query. So that time it will pick directly from the storage. Yes, correct. So, and again, it's based on the session ID. As I said, it's not based on users. So, if the session IDs are different, different private SQL areas will be created. Yes, Girish. Yeah. Okay. So let's move on to the next one, which is also very important one, which is a redo log buffer. Okay, we call it. Now let's
Hi
understand what
Vishnu.
is this.
Hi Vishnu,
Yeah.
this is Sudhir.
Yes.
So
Yes.
like the PGI can access the data, I mean the read the data from directly from the data storage, right? As you said.
Correct. Yes.
So it happens only whenever there is a query, no, the first time it is accessing the data, or so in what scenario it will happen?
Yeah, so this process, no, it's called direct path read generally. Okay, that's a word which Oracle uses. So direct path read is generally used when so that's what. So it's handled by the Oracle algorithm. Okay, there are some queries where I'm not getting a quick example to say that, but where this whole like complications is not required of this SGA. So that Oracle will handle automatically. Like we can't control that. It's a DBA concept, very advanced. But what Oracle does is, so those things it will not go to this all this hardware. It will directly pick from the storage disk and put it. Like let's say you want some table name or something. Okay, so why it should go to this all SGA? It will pick up those table name from the directly the storage disk, right? Something like that. It's called the direct
Oh,
path read method. Yeah. Yes, it is.
okay. Thanks, sir.
Yeah.
Thank you, Vishnu.
Generally, there are like this method, right? One is this one, which is called the direct path read. The other one is called a scattered path read. Okay, there are two types of path read methods. Generally, we this word is used in, but again, these are like some jargons. You don't need to remember all this, so that's why I'm not using that. But this is called direct path read, and this is called scattered path read, where we go through this all this process, right? This SGA inside different memories we use, so that's why it is called scattered. Okay, so yeah, just an extra thing. Okay, so let's move on if no more question from this database buffer cache. Yeah, so next is something very important, though it looks very small. This is also very important with respect to the backup and all those stuff. Okay, so this is called the redo log buffer. Now the name itself, sir, you can understand, right? It's something like like a backup, or it's like where you get the whether your data is like when you're doing some changes, okay, when some unexpected errors occur, you need to get that get out of that system failure, right? You should not lose any data. So that's why we have something called a redo log buffer. We will see this in very detail as we progress, but for now you just know here that every time whenever a table or data is altered or something, whenever a write process happens, that same thing will be written to the redo log buffer also at the same time, and that will be stored by this redo log buffer inside the redo log. So what basically this redo log buffer will do is whenever any table alteration happens, it will obviously write inside database buffer cache and also inside the redo log buffer. So whenever you need to redo it, like so what is generally happening is like you alter a table, some table A. So before when this alteration is happening, the old table A, like table A1 and table A2 before alteration. So before alteration, it is table A1 that will be stored inside the redo log buffer for some duration, okay, until that also we can control. We will see how we control that in further lectures. But what I meant to say is here it allows us to undo something, okay. If some failure happens or something, automatically Oracle can undo that changes from this redo log buffer. And don't confuse with the rollback. Rollback is totally different. We will see that what is the difference between rollback and redo. Redo log buffer is just a small buffer where if some failure or something, some system crash or something happens, Oracle can just undo that change, or it can pick up that change and publish it properly. Okay, so that purpose this redo log buffer is used. We will see what is rollback in detail, which is undo process, okay, as we progress. Yeah, and after that there are some like it's not that much like important, but there are some other components like Java pool. So Java pool is nothing but here some Java classes are stored, okay, which is required for the processes and all. And there's stream pool again for streaming purpose, okay. This it handles all the streams, okay. So it's again an advanced concept, not so important for us. We can't control that much, so that's why we are not seeing it for now. So that's regarding the components. And yeah, there is a large pool also. Again, these are like it's not that much important to know what it is, like not important for us, okay, because we can't control again these things. So that's why we are not looking into it. It's again a high end DBA concept, so we are not looking into that. Yeah, so the redo log, once again, I guess everyone is clear, right? What is redo log buffer? So this process is constant, okay. So writing and deleting. So whenever a redo log buffer is, it will write the data from the log, it will delete. Write the data from the log, it will delete. Whenever some alteration happens, it will not keep that data for very long, okay. This process is constant. It keeps on doing that after a specific time. Again, this is again the memory management times and configuration, how it is done. We will see that. Anyone, any query?
Hello.
Yeah, in overall architecture, anywhere, any query, then we will move to next other way. Yeah, yes, go ahead, someone.
Yeah.
I think,
So,
yeah, I mean,
so what is the default value for SJ and PJ?
yeah,
And
see,
on what?
that we will see in the further lectures. We will learn about block size and all. That time it will be more clearer. Like that value we can change, okay, but generally there is something called automatic memory management in Oracle. So many people will use that one directly, so that, and it is very efficient also. So as a performance engineer, generally what we do is we check whether that is switched on or not. That is again a configuration which we check. Okay, that automatic memory management is working properly or not. That we can check. So that is where generally this amount of data like KB or MB, we don't worry much, because that is. But how much free is there? That we check, because even for the automatic memory management, if it needs 5 GB, then 5 GB memory should be there available in our infra, right? Then only it
Yes,
can do.
correct.
Yeah. So that we check. Yes, correct.
And how much RAM should be there?
See, these are like very perspective concept. I meant like with respect to the application. So generally, whenever you see a bottleneck, like based on the amount of data which is coming, okay. So the amount of the block size which is coming, if there is some memory blocks happening, which we can analyze using our statistics, we need to increase the memory.
Okay, okay.
Yeah, that's all.
Vishnu,
We can see that like 100% utilized or 80% utilized. Like we see the CPU and memory in our load test. No, similarly in database also we can see that based on the statistics which we generate. Okay, and from that we can find out whether it's a memory problem or the query problem, because the problems can be either one of these only, not anything else. Most of the time, 99%, either the query is not optimized, the way it is being executed, or the procedure what is being executed, or the database configurations are not optimized, the memory optimizations or the memory configurations.
Vishnu, one thing.
Yeah,
So
Anil.
yeah, so this PG or SD all are a part of cache memory. So this will be allocated in the RAM memory, right?
Correct, yes, it will be inside the RAM. Correct.
RAM.
And one more
Okay.
question.
Yeah.
Like on the application front, we will set up this heap size, right, from 4 GB to 8
Yes.
GB. So
Mm.
this mean
Yeah.
max size. So in the same way on the database end also we will define this
Correct. Yes.
this this, right? Okay. So what
Yes.
is
Yes.
that?
Correct.
It is also heap memory or some other name terminology will be there.
No, it is some other terminology. You will see that parameter name and all. No, there are different memories. Okay, different parameters. Like there are different caching memory configurations. If we do that, we will see.
Okay, thank you.
Yeah. This is not the end of the architecture. We will be continuing from here. Like again, we will see these in detail, especially the shared pool and the buffer cache. That time we will, because next what we will be speaking is the block size, the extents, the table spaces. Okay. So when we go this step by step, you will be automatically understanding what to be allocated, how much to be allocated, and those stuff. But now, if I say something, it might look little out of the box. So that's why I'm not calling those terms out. Generally, now next what we will be seeing, right? Like shared pool, we will see in detail what is data dictionary. In data dictionary itself, there are multiple different components, okay? Or even the shared SQL area, there are different components inside the shared SQL area. PGA, okay? If even the database, right? Inside the database block, because every data is stored in blocks, okay, and that database block is further divided into block headers and rows, okay. So how that memory is being controlled or managed, that we will see, okay. Then inside PGA there is session area, private SQL area, cursor area, SQL work area, that we will see. Then in the data dictionary cache, we have result cache. Inside result cache, that we will see like what little bit more detail. What is this result cache? So we saw, right? It's a result of the commonly used queries which is stored inside result cache. But in detail we will see. Okay. Again in PGA, how it is done. See, we saw what is done. Now how is it done? Like how is the writing process, or the how is the server process happening? Okay, like when is it done, why is it done, and all those questions that will also be coming in the further lectures. Before we finish this database architecture part, now all this will be covered. Then also like how a DML is processed. DML is nothing but data manipulation language, or we can say whenever some queries run, okay, we call it DML. So how, like, what happens when we run a DML code, okay, that we will see. And when the user commits, what is the change? So all this will be covered, okay. So that time all these queries will be clear. I think let's if no more queries for today, anyone, any query?
Hi Vishnu.
Uh,
I have one question.
Yeah, Rajesh, please go ahead.
Yeah, so I have question regarding this redo log. So this
Yeah.
redo log, it will only it will only come into picture when we are doing any update, or it will
Correct.
also or if we are doing any read statement as well. So at that time also redo log will come in the picture.
No. Redo log will come into picture only when you are altering some thing in the table. Otherwise, there won't be any redo logs happening. Yeah.
Okay, so in this it will store both the old data in the table as well as the new data in the table.
No.
Whatever
Whatever
we are
part
making.
you are changing, like whatever table you are changing, there can be multiple tables in the database. So only the table which you are changing will be written in the redo log before you change it. So that if something goes wrong, also Oracle can push it like back, or like without the whole database failure or some table failure, right? So that's why.
Oh no, like if you are making changes to any particular table, okay. So in
Okay.
that case, so whatever table it will contain earlier before making changes. So this redo log it will contain both before making changes to the table as well as after making the changes to the table. So
Yeah.
that in case of failure, it can take back the old data.
Yeah, so that is a good question. So basically, see, what is this redo log buffer is, first of all, it is for not losing any data. Okay, that is what this redo log buffer does. We don't want to lose any data. So whenever any new entry is created, like some insert statement or some update or delete, create, alter, drop, or some other such statements, okay, what this redo log entry will happen. Okay, so what redo log buffer will do is, there is a log writer process already. Okay, so what this redo log buffer will do is, that log writer process will write that log files into the redo log files. Now here, this is used for recovery purpose. Okay, so this recovery purpose, we won't be storing the new one, right? Only the old one.
Okay. Oh,
Yeah. Okay. And also this redo log buffer is also called a circular buffer. Okay. There are different types of buffer. We call, on one of that is circular buffer. So circular buffer is nothing but, it's like a first in first out, something like that. So whenever the memory inside is fixed, so if some new thing comes, it will delete the old one, it will push the new one in that way.
okay, okay.
Yeah.
Thank
Yeah. Yeah. Rajesh, yeah. Any other question,
Yeah.
anyone?
Yeah, hi Vishnu. So in the further
Yeah.
classes, are you going to cover any the hands-on or practical sessions running the
Yes,
index
yes.
queries and
Because
all?
see, now what we are seeing is database architecture. Now after this, we will be pulling out reports and all, right? Pulling out reports, creating the statistics. Because just by observing the database, we can't say like whether it is performing bad or not. We need to understand from the query level. So how, which query, what query, and what is the problem? Where is the bottleneck? For that, we need to pull the statistics, the reports. So that time we will go to the database, we will run the queries, like for getting those statistics. That we will be doing next. And then after that, what we will be doing is optimizing it. That also we will be seeing, like how to tune the queries based on the statements, what is being used and all. What all is the standard procedures which we need to follow when we have some queries to optimize it. So that we will be seeing extensively when we go to the query section.
Okay. So any prerequisite knowledge is required like for
Yeah.
this?
Yeah, so that's why I said, so basic SQL knowledge is good, because when I execute some queries, okay, like some example, I have some queries like this, okay. So to understand what is select star from, at least like, not that you need to write this query, because anyway I will be giving these queries, generally whatever is used for performance engineering, generally, and you can edit over this based on the parameters. But you need to know, like, totally blank about SQL will be difficult, but little bit, some basic knowledge on SQL. No, Rajesh, we are not covering any NoSQL. It's a little out of scope for this course, because based on the time and all.
At least we can do
Okay.
any comparison with the with the SQL queries.
Yeah, I can try, but based on the time limit, I can't commit now, but I can try. Yeah.
Okay.
Because again, this
Yeah.
is an expensive course which I need to finish in 20, I think 20 plus hours. So let's see
Sir,
if
one
Okay,
general
possible.
so the
question.
same. Yeah,
Yeah,
Naveen,
Suresh.
please go ahead.
Yeah,
So,
Naveen.
general question, recently I saw in our application the inactive sessions are drastically increasing,
Mhm.
and I don't see the resources availability on the database side. So some of
Okay.
the nodes are going down actually. So we couldn't find what could be the reason. So
Okay.
most of the things I observed is like OTB functionalities are causing the issue.
Mhm.
So how do I rectify it? Which is session is consuming more? Why inactive sessions are increasing drastically?
Mhm.
Uh, yeah.
First of all, see, there you need to check the count, okay? Inactive and active session count. If the
Okay.
percentage of that difference is very high, then that there is some issue. Otherwise, if the percentage is not that high, it's usual. You can leave it. Like if it is below 1% or 2%, okay, that inactive to active ratio. Then next, what you need to do is the usernames and the programs which are in that inactive count. Getting my point?
Okay.
Like
Yeah. Yeah.
what are you, if you have some usernames or session IDs or whatever inside that program. So in that way you can group it first. Group it by the username and the program. Okay. And
Okay.
then you can find more details like what is the let's say the terminal or the session ID or the serial, okay, or what is the process. Then you will come to know which is the bottleneck there. Also, you should know like whether it's a dead connection, okay, or ideal connection, idle
Okay.
connection. So we will see as we progress what is this. But yeah, it's again like very without seeing the application, I can't say like what could be the issue.
Okay. Okay. Fine.
Yes.
Yeah, hi Vishnu. Suppose like if I after covering these Oracle database engineering sessions, so
Mhm.
will this helpful for any other database also? Because depending on the project, the database will change, MongoDB or some other DB. So any similarity will be there, so which will be helpful for the engineering.
Yeah, first of all, it like here you will learn extensively on the SQL language tuning, right? So here you what this mainly will give you is a very much confidence on the database side, whether it be any database. That confidence is first required, like because whenever we speak about SQL or some database, we directly go to the DBA. But once we finish this course, you will have that one, like it's like, okay, I know some Java programming, or let's say I know some JavaScript. That time learning Java programming is easier. Somewhat that confidence will be there. Similarly, this course will give you that confidence, okay, that database is not that a big concept. It can be also easily understood. And it's all correlatable with each other, like even the architecture. If you take the SQL architecture, MySQL and Oracle, they are like you can compare. Okay, it's correlatable, so it's easy to understand. Yes, in that way.
Okay, thanks, Vishnu.
Yeah. Okay, then we can stop here. If no more questions, we can continue the next class.
Vishnu, what the timings of the session is same or it's going to change?
Right. So as I said, like it's based on the audience. If majority of the audience say like if we come into some consensus like okay we need to change some time or maybe increase the time daily and keep it alternate, we do that. But that we can plan once the audience is fixed and we can like majority what they say, we can change it. Yeah, based on that. Yeah. Okay. Thank you all. Meet you tomorrow. Have a good. Bye.
Thank you.
Thank you. Thank you.
Thank you.
Bye bye.